We'll hand it over to you, and we will get started.
All right, thanks very much. I'll just do a little video intro before I get onto the slides. It's great to see so many people here. And I will go straight to my presentation as long as I can get share screen to work. This technology is always slightly confusing, but I think we can make this work. Can everybody see the slides? If anyone
looks great.
Okay. So hopefully you can't see me. So for do-it-yourself assistive technology solutions, this is the first of our technical sessions, or more technical sessions, as part of Makers Making Change Presents. I'm going to hit you with a number first. 94%. If you could save somebody 94% of the cost of assistive technology by using 3D printed devices, I think you would do that. It's pretty compelling if you can save that much money. And my screen is automatically advancing, and it shouldn't, sorry. So that is actually a stat from a paper published in 2018 that was looking at the relative costs of 3D printed assistive technology. So definitely compelling, definitely worthwhile for saving your clients money. One thing I like to get into early in the presentation is our sponsors, and we're not here without any of these folks. So thank you very much to the Government of Canada, the Google Foundation, Winnipeg Foundation, RBC Future Launch, Calgary Foundation, the South Okanagan Community Foundation, Vancouver Foundation, and the Craig H. Nielsen Foundation. All of these groups have helped us over the years deliver services, create devices, and help people all over the country, in fact, all over the world. So what I'm going to cover today is where you can get do-it-yourself assistive technology designs, or you can get the devices made for you yourself. I'm going to go into a little about using 3D design to design 3D printed assistive technology, and also to locate the resources that will work for you in getting the devices that you need, either for your own use or for the people around you's use. Oh, one thing I should say is, if you have questions, drop them in the chat, and Courtney will stop me, and we'll answer them as we go along, rather than waiting for the end. So I'm perfectly fine being interrupted. So this is me. I'm the Central Region Organizer for Makers Making Change, and we're part of the Neil Squire Society. I am an engineer and maker, and I've been working in energy projects all over the world for many years. When I'm not doing this, I work with small computers, some very old and ill-advised computers, and I also spend quite a bit of time drawing. I work for the Neil Squire Society, so I'm receiving a salary for this, just to disclose that fact. So, about Neil Squire. We are a society we've been running since the early 1980s, and we use technology, knowledge, and passion to empower Canadians with disabilities. We believe people of all abilities should have the opportunity to live, work, and play without barriers, and that's how we live, and this is how we do the best help that we can. We started with Neil Squire. Neil was an athlete, and in the early 1980s he was involved in a car accident which left him quadriplegic. His friends and family rallied round and realized there was a huge change in Neil's life, that he was really not able to communicate or do the things that he'd previously done. So a relative and some nearby engineers got together and developed some very early assistive communication technology. And this is Neil typing on an Apple II, an ancient computer, using a simple sip and puff switch to key Morse code. And that's really how we got started, by a group of people helping someone and then developing projects further. Now, unfortunately, Neil's no longer with us, but the work that started then goes on as part of the Neil Squire Society. And the Makers Making Change program, as part of Neil Squire, is a fairly new initiative that connects people with disabilities and volunteer makers to deliver low-cost, open-source assistive technology near where it is needed, rather than ordering it from a catalog with markup. It's more to be community involved in the design and use and applications of assistive technology. And we've done a variety of events and continue to do so. So we've done Access Makeathons, which are a whole weekend event where we bring together engineering students and to develop and prototype assistive technology solutions. And in many cases, this is the first time that engineers will have had to face some of the issues that people with disabilities face every day. We have our website that allows you to connect with other makers and request devices and see the designs and even submit designs for your own. We've got many, many designs in our library, and I'm going to go over them, but we have our pen ball for writing and say our very simple key turner, which we give away so many of these. They are such a simple device, and they literally open doors for people. We also run events with organizations such as lip sync build events. That's what the picture in the bottom of the screen has. And we've also in the last 2 years started doing a lot more work with assistive and adaptive gaming. For us, this wasn't really on our horizon until we realized that thousands and thousands of people with disabilities game every day, and we didn't know this, and we realized that there was some very simple technology that we could help develop that would make gaming much more fun and much more inclusive. And thankfully, folks at Microsoft thought the same. So this has been working very well. So quite often I'm talking to people who work with assistive technology every day, and so they know what this is, but maybe some of you don't. So it's really any item, piece of equipment or product that is used to increase, maintain, or improve the functional capabilities of an individual. And that includes my reading glasses. I'm over 50 now, and you know, type has got all funny and small. I don't understand it. So it could be a walking cane, it could be a wheelchair, it could be a reading system. There are so many because everybody is different. And the really key part about assistive technology is that one size fits one. There is no global solution that helps everybody. This, if there's anyone from the computer industry, this is a problem that does not scale well because every end user needs to have different requirements. And assuming everyone will be the same is not an option. So we've got the assistive technology side. What's open source assistive technology? Now, again, if people in IT, they're already about knowing what open source is. But many of the devices that are sold as assistive technology devices are closed. They're patented designs, they're copyright, and therefore one manufacturer or one designer limits how you can get that. They get to set the price, they get to set the availability, and in some cases you get really good assistive devices that go off the market and they can't be remade because the original company is closed, but it's patented, and so nobody can make it again. So the people who need it aren't helped. Where open source gets around this is that our designs can be freely used, modified, and shared. There are a variety of licenses known as Creative Commons licenses that allow you to share a design without losing credit for it. There's organizations like the Open Source Hardware Association, which certifies particular electronics hardware that has been developed in an open manner such that it can be shared, improved, and fed back to make an affordable, better product for everyone. So here's an example of some of the things that we have. This Pom Pen Holder is very popular for people who lack the ability to grip something fine. you would be amazed the number of times that something requires a pen signature. Even in these days, there'd be some final legal thing that needs you to move a pen. This costs about $2 to 3D print. It's got a machine screw and a nut in there and a pen, and the whole design files and the whole instructions are on our website at makersmakingchange.com/project/Pom Pen Holder. Anyone with a 3D printer can make that now, can make it for anyone that they know. They can give it away, and there's no problem with that. We want people to use it. Another one is our very simple Raindrop Switch. For many people with physical disabilities, switch access is the window to the world. There are controllers on wheelchairs that will operate devices all through the home. They'll open doors. You might be able to operate your remote control on your television with it. But many of these things are accessed through simple switches. And commercially, these switches are very expensive. I mean, our Raindrop is modeled on a unit which is roughly $70. Ours costs about $7 to $15 to make. It's a very simple build, and we've had volunteers from all over Canada build them at events hosted by TELUS, and we're grateful for TELUS's support in building all these switches. And it's a very simple build indeed, and for many people they may need a lot of these switches. So if it can be $7 each as opposed to $70, that's a major saving. And of course, if your mobility is limited, you need to have these switches exactly where you need them. Commercial mounts or switches exist, but they can cost a huge amount of money. But we're finding that with 3D printers and simple things like T-nuts meant for building furniture, we can make very cheap but strong tripod mounts for many switches and other assistive devices. So this is another way that we can leverage simple makerspace technology to make people with disabilities' lives easier and more easy to afford the devices that they need. Another thing that we have, and we picked this up from a kindred group, AT Makers, who are based in Florida. Many of the computer interfaces to take input from switches are tremendously expensive, and really all they are is a simple USB interface. This key switch interface, while very simple and it's got some limitations, I have to say, allows you to have up to 5 switch inputs completely programmable, and it will act like a USB mouse or joystick or even a partial keyboard. And this is very, very inexpensive. But what really makes it for me is the fact that this is so easily customizable. The device operates in a simple programming language. It can be modified by the user. It can be experimented with, and it's not like it can be broken by playing with the code. The code can be put back and the original function can be restored. And we can do this for all about $30. This is on AT Makers GitHub. Strongly recommend taking a look at that device because it's so simple and yet pretty powerful. And all of these designs can be freely shared. Anyone can take it, modify it, improve it, give it away, and there's no limitation on that. Another one, and this is one we've been working on for several years, this is the lip sync. We received a lot of funding from the Google Foundation to help develop this. This is a sip and puff mouse. A mouse for your mouth is basically what it is. If you have no hand movement or limited hand movement, a traditional computer trackpad or mouse is completely not going to work for you. This, however, operates a mouse through small head movements and sip and puff for clicking. It's compatible with most systems. It works out the box with desktop systems and Android. There are Bluetooth versions that work with iPad OS, and it even works with the Xbox Adaptive Controller. So we know people who game with these sip and puff mice. It's completely open source. It's 3D printed. Absolutely everything about this is on those links, makersmakingchange.com/project/lipsync. That's the source code. That's the PCB design. That's the 3D models, that's the manuals, and we built hundreds of these and given them away. It's a very successful device, and it's completely open source, and we've had people modify it to do things we'd never thought possible. That's the great thing about open source. Somebody gets the idea, tries it, and extends it. And that's definitely happened with the lip sync. So there's definitely advantages in this whole open source DIY assistive technology thing. The cost's much lower. It allows you to collaborate, especially collaborate with users of assistive technology so that they can have a better product. They can have actual input into what they need to use. So it's customizable. It avoids the wait times of delivery and maybe avoids the disappointment with something that doesn't work. We can replace discontinued products, like the picture on the upper right. There's a device called the AbleNet Rocker Switch that was available a few years ago. It's been discontinued. It's not the best switch in the world, but for some users it's great. So we've made an open source version of it, since AbleNet don't distribute theirs anymore. And ours is almost as good, but for the users who particularly need the rocker switch, it replaces a device that's not there. And you can customize many of these designs the way you want. And yes, the one on the bottom right, the pink on purely eye-searingly horrible colors, that was one of mine. I am not ashamed of that in any way. If somebody wants a bright pink switch with a neon green cable, I will make it for them because I can. Not everything is so perfect though. Open source assistive technology needs access to tools and equipment, and these are things that aren't in everyone's home. There's the cost of materials, which although not high, they're specialized, and you quite often have to get them from special suppliers or mail order them. In the case of the 3D printer, you can't just leave them around anywhere. It needs a safe, stable place to run it. Sometimes you get 3D prints that don't work, and that picture is me coming into a 3D printer that had been printing for 23 hours out of a 24-hour print, and everything had fallen off the print bed. So I made a really, really nice bird's nest that day, which I had to throw out completely. So sometimes the printing can be a little wasteful, but usually we get things right. The designs themselves are not always as strong as commercially available devices. And we have to be aware of that. And there's other safety issues and surface quality issues. And 3D printing isn't fast. It can take several hours to make a part. And that's several hours that you're not doing anything else with a 3D printer. And they're still not quite ready for everybody's home. Sometimes they'll go wrong in ways that are not quite how you'd expect. So they are getting much better, but you know, I wouldn't say they're quite ready for, you know, everyone just to have as an appliance. So now I'm going to go through a bit of the process about how we develop DIY assistive technology. I'm going to go through the decisions you need to make at the start, how you can find it, how you can customize it or create it, how you can actually make it, and then take those designs and share them with everyone else. One thing that's probably the most important thing right at the start is like, do I have to make this? Is there already a device that's available and affordable that will do this? If there's something that's going to work and can be afforded, we would actually probably recommend that. It may come with a warranty. It may be more widely available. Some of these things, you know, it doesn't make sense to 3D print. We could 3D print them, but we wouldn't make them so well. Things including anything to do with contact with food. 3D printing isn't yet food safe, really. So it's like, you know, it's all down to judgment whether the user would want it to be 3D printed, and from a technical point of view, whether it's safe or useful to do that. So before we rush off and design something, we have to consider that the 3D printer is a good option or not. You have to really consider safety with 3D printing. Sometimes the edges can be left very sharp, and that might be an issue for someone who's handling something day to day. they can break. They're not always as strong as you expect. Heat affects 3D printed parts quite badly, and unfortunately, the standard method of steam sterilization doesn't work for 3D printing. 3D printed parts would just melt and collapse. 3D printing involves a lot of small parts that shouldn't be used near people's mouths, and the 3D printers that we use and that we can afford are not food safe. There are food safe 3D printers available, but we can't really afford them, and maintaining a safe chain of cleanliness that's up to food grade standards is really rather difficult and involves a lot of licensing. And that's not really what we can recommend for most people. So some of the filaments are not produced in a food safe manner. The printers themselves have got parts that may have traces of things like lead in them. Even though they're safe to handle, they're probably not safe to have in your food. And there's a photomicrogram of a 3D printed part here, and you'll see there's lots of little pores in it, and that's exactly a perfect bacteria trap. So this is why we really, really don't recommend our parts to be food safe. Now I'm going to move to finding these designs, because the really important thing is, like, if you have a need for a device, or if you want to develop or print a device, it shouldn't be up to you. And there's lots of people all around the world who are developing these. And so we hope to create repositories of the best assistive technology. And there's really two kinds of places that you can find these designs. There's open source DIY repositories that are specific for assistive technology. Most of the designs are open source. Some of them have got copying restrictions on them. Our ones, we try to make them as open as possible. What we try to do is include as much useful information as possible. The 3D model, the design information, all the parts that you need to go with it, and the original design file, so that if you have that CAD program, you can modify it. People who are working in open source assistive technology are pretty careful to include as much as they can, because they know that customization is key to assistive technology. And then there are general 3D model repositories. There you'll find assistive technology mixed in with absolutely everything else. I mean, there's a site called Thingiverse that has literally far more than you could ever imagine being needed anywhere, but it's all out there. Most of those designs are open source. Some of them cost money, usually a reasonable sum, and you have to be aware of these costs when dealing with a general model repository. And it's sometimes some good designs are free, and sometimes not so good designs are expensive. You can't really tell until you've taken a good look, or perhaps even made it. So the open source assistive technology repositories that we have, of course, Makers Making Change is up the top of the list, because of course we are. There's also ATmakers, atmakers.org. They're very active on Facebook, and their pages are great. And Bill Binko, who runs that group, is very, very active and keen on all these devices. Careables as well have many good designs. Tom, Tikkun Olam Makers out of Israel are a very, very active group. And IKEA has their Thisibles assistive technology. Admittedly, it's to help with IKEA furniture, but I basically live entirely surrounded by IKEA furniture, so this would be very helpful. And IKEA are definitely developing more designs that might be more general. So these are the ones that I know of right now that are purely for assistive technology. So if you went to our site, which I hope you do, makersmakingchange.com, you can sign up to and be involved in the forums, or upload your own models, and find out what's going on around you with Makers Making Change. You can find devices in the device library, that's under the projects heading. And then you can take those devices, download them, find the instructions, and make the device for someone who needs it. One of the other features, maybe I should go back, one of the other features is that you can request devices to be made for you or for some, if there's a maker in the neighborhood or nearby, and we can find makers to make things. So even if you're not a maker, even if you don't know any makers, but you need a device, we'll find a way of getting it to you if you request a device on our website. So I'll go back to the design process again. One of the key and more useful techniques is called design thinking. It's basically a way of developing empathy in coming up with products. I know I'm a bit of a compulsive designer. I will go, yes, I need to design this thing because, and if anyone asked me the real reason of who I was doing it for and why I was doing it, I would probably wave my hands a lot and not have a good answer. So design thinking is like slowing the process down. You have to empathize with the user and come up with like what, understanding what they need. You define the product. You come up with ideas. You test them. Sometimes they work, sometimes they don't. And you go back and you refine through prototyping again. Maybe you refine your idea and test and hopefully come up with a good product. It's very iterative. It can be slow and messy, but unless you're actually involved with the person who needs the devices, you won't end up with a good design, because trying to come up with useful designs that you have no lived experience of needing, that's not going to work. So this is actually a sketch from one of our engineers' processes to come up with the Raindrop Switch. We knew there was a small switch needed and it needed to be inexpensive. So a design was sketched out. We looked at components that might be able to fit in. So that's the middle picture is a very inexpensive tact switch and an audio cable for like a mono audio cable. And the beginnings of a 3D design go around it. There's the first 3D model of the case, and then the model of it printed, and then a whole bunch of green ones printed on my 3D printer, and finally the printed design. And this model took quite a bit of iteration to find out what would work, what was affordable, what had good activation strength, what was easy to build, and all of these things are not immediately obvious from when we first start. Most of our designs and most assistive technology does need to be able to be customized. And one of the things you can do with a 3D printer is you can scale a design. You can make something twice as big. You can make something half the size. This isn't always so great if you have fasteners, say, in your design, because some of these nuts and bolts don't come in all the scaled sizes. But if you need something that just needs to be a little bigger and it has got no like fasteners or anything that needs to fit together, you can scale a design, make it bigger or smaller, say for bigger or smaller hands. You can customize it for color. You can add people's names and logos. The middle picture is showing a group of access buttons that I made, really designed for gamers. I customized the tops, I customized the color. Yes, there may be glitter involved too, because that's what we can do. And they work very well, and they're also extremely decorative. So as I said before, one size fits one with assistive technology. It needs to work for the user or it doesn't work at all. So as I said, scaling works sometimes, and some of our designs can be easily set up to change size. There's a variety of design packages that allow you to specify sizes of components, sizes of clearances, and then if you change the size of the model, those components will not change size. They'll change position relative to the model, but they will hopefully still work as a coherent design. This does require a little bit of extra work from the designer, and I have to say that we'd want more of our designs to be more like parametric, as this is known, but we're working on that and we want to improve that, and especially if there's any volunteers who would like to help, we'd be very happy to share some of these issues. So when you get a 3D printed design, what is it you're actually dealing with? sometimes you'll click on the get the design and you get this file that's called an STL file. And what do we do with that? It's basically just the geometry of the model itself. It's got no idea of what the model is for. It's just simply the shape. It's universally used. It's a very simple file format, but it's really hard to edit. It's kind of like final format. It's like a PDF. You can't mess around with it. It's going to end up the way, it's going to look the way it was when it was produced. You can't really change it much. You can scale it, but you can't really do much more. If you share the design files, however, it allows people to modify it and change the intent and change the interfaces to the design. Thingiverse.com is one of the major design websites, and they have a service called the Customizer. Shown at the bottom right is a very, very simple pen holder for people who maybe couldn't grip a pen normally. And this is, it's not actually a very good open assistive technology device. However, it's something that can show off the customization process. And had we had better technology, I would actually have live printed one of these to a size and shown that these things can be customized in a few minutes and made quickly. But this design allows you to change the size of the finger it will be used with and the size of the pen, and it's got a wide range, and you can see it previewed even on the website. Then you press a button and you basically get the design to download at that size. It requires a bit of work by the designer to set up, but once it works, it will keep working for a long time. One other thing that in our more interactive sessions, we would have had a demo of a package called TinkerCAD. TinkerCAD is an online CAD package. It runs in your browser and it runs quite well. It's from Autodesk, the people who make AutoCAD, the very expensive CAD system. It's very simple, but you can do some pretty neat things with it. Unfortunately, in the roughly 45 minutes we have for a presentation, I don't think we'd be able to get you even started on this. And also I'd need to be sharing screens and introducing you to everything, all the concept, and there's a login required, and if you're on a tablet, it's not going to work. So probably best if we introduce that we have worked with a British company called PrintLab to develop some curriculum for design thinking and assistive technology development. This is called the Assistive Design Device Academy. If you go to the URL classroom.weareprintlab.com/p/assistive device academy v2, you can follow along that course for free. I think it's meant for middle school students, but it does step through the whole design process and how to use TinkerCAD very well. The design we're showing here is their can opener. It's for levering the top off a pop can. It's something that can be designed very quickly and can be done online at no cost, and you can create a design that can be downloaded and printed very quickly. And they provide a final design, which may not be exactly the same as you come up with, but it's one that works, and it shows you how the design works and how you would come up with this idea and make it to help someone. So, our options, and I'm just going to take a drink here, and I don't know, Courtney, if there's any questions, but I'll get back on this slide very soon.
No questions yet, but I am learning lots.
Oh, thank you. I'm glad someone is. All right, so our options. How do we make or get these devices? You can make them yourself. You can connect with a volunteer, or you can go to commercial service. And all of these have their pros and cons. So there are a number of organizations. We're focusing on Canada because we're Canadian, such as the Tetra Society and March of Dimes, who have volunteer maker programs. And there's, of course, ourselves, but I hope you'd remembered about makers making change this far into my talk. There are also makerspaces. Now, makerspaces are a little difficult in this time of COVID because public spaces and control of public spaces is a little difficult. We've given some URLs, and this presentation will be available at the end, of places you can find makerspaces across the country. Many libraries, when they open again, have 3D printers, and there's a large and curated list of all the libraries that have them. Colleges, high schools, and universities have 3D printers. Some of them have public access. It's really kind of like a, find your friendly neighborhood maker and start asking questions. But hopefully the lists we've provided are helpful for you to find volunteer makers. There are 3D printed commercial services, and while these can be really expensive, the options for materials and processes are much, much higher. In fact, one thing I discovered recently is that Windows 10 has built a built-in commercial 3D print service. If you download a 3D model and double-click on it in Windows 10, it opens in Windows 3D Print, and it offers you various commercial services to print things. And yes, they're expensive, but considering that 3D printers have really only been around for a little over a decade, it's pretty good that it's now a recognized service that you can get something made from your desktop. So number of companies, Shapeways is the really big one, 3D Printing Hubs is another one. The other ones are maybe slightly smaller ones. Digitmakers, the local 3D printer company who just happens to make things. And they've also been really good volunteering, making assistive devices for some of our partners. So these groups are all over, and there might be a good service near you. So why would we share these designs? This is really that, you design for one, and maybe your design can help everyone. Quite often, if you come up with a design that's useful for you, or someone around you, maybe if someone else sees that design, they could say, "Oh, this could be made easier that way," or if you added that, we can make this work for me and another cohort. And you get a lot of feedback about how to improve your design and how it might be used in ways that we'd never expect. The open source model doesn't need to be just supported of its own accord, but the idea of sharing designs and sharing that there are useful designs out there definitely helps with the problems of isolation, of like feeling that maybe that I'm the only person with my disability, that I am, that there are other people working on these issues, and you can make the design that you came up with work for so many more people. And that's the thing we're discovering. Makers Making Change is one of the largest organizations doing this, and we quite often come across a little group in another country or in a county somewhere, and they say, "Oh, we thought we were the only people doing this," and they've got great designs to share that no one else knows about, and equally they could use some of our designs. So it's like we're so glad we found one another. So that's where open source works really well for assistive technology. So when you're providing your own designs, what is going to be useful? At the very, very least, provide the print files, because otherwise no one else can make it. A picture is great, but if I can't make things from a picture. Ideally, include the original design files so that someone else can make and modify it. All the parts that you've used. Not everyone can get particular hardware. Canada is particularly special because it's not quite metric, and it's not quite the same as the US, and it's not quite the same as anywhere else because we're Canada. Instructions are really helpful, but good instructions are really hard to write and very time consuming. Even just a sort of short list of the things that are kind of difficult or not obvious. And this is where sharing with other people really helps, because someone will come to you and say, "I can't build this," and then you suddenly realize the things that you thought were obvious were not so obvious. It really helps to say why I designed this. Who is this designed for? So that it helps people find it, but also it helps people to extend the design. And pictures. No one will ever know what's going on without pictures. So You've all got cell phones, as many pictures as possible. You can't have too many. So, document as you go, and even if your design isn't ready, submit it to a repository. Put it up on Makers Making Change, put it on Thingiverse. Especially at Makers Making Change, we have a forum that people can take your designs and discuss them. If you've got questions about your own design, you can talk around that, and we can have ideas and how to make it do more or how to make it easier to make. So it's important to get your designs out there and see how other people would use them. I put this slide in, and it's a bit of a derail from the rest of the presentation. You may have seen a lot of makers making PPE as a response to COVID-19. Now, Canada's a little different in this. If you make PPE in Canada, you must have a license. And if you're making representations that you're making PPE and you don't have a license and something goes wrong with the PPE, you can be sued. So in Canada, it creates a liability when you make a PPE. It's not as if there's a first aid can be pretty much done without being sued. If you make PPE in Canada and it's not licensed, you could be sued. So we have decided to stay away from that. Rather than making face shields and other devices, we've decided that the hard part is that sanitization, making sure that what you make doesn't cause infection for other people. So we've been looking at ways of sanitizing devices. Plastic products are somewhat hard to sanitize. There's certain chemicals that you just can't use. We've also been reviewing a lot of the 3D printed devices for safety and accessibility. We found, unfortunately, a lot of the access devices, like door grabbers, create access hazards for people with disabilities. They create like an attractive nuisance. Say if you would attach something to a door, it would mean that if it broke and hurt someone, you'd suddenly created a liability. In some cases, it makes the door harder to open for people with physical disabilities. So we have done our best to monitor the situation and provide best practice around sanitization, but we've put out guidelines, and I invite you to take a look at the link, makersmakingchange.com, COVID guidance for makers. We don't have many designs on there, but it's mostly about best practice and how to deploy your designs mindful of people with disabilities. So I'm just beginning to wrap up this talk. So we have a whole list of resources here for where you can find design resources, where you can learn more about TinkerCAD and PrintLab, our partners. One absolute champ at this whole DIY AT thing is Therese Wilcom. She's a professor in New Hampshire, and she has a series of books called Assistive Technology Solutions in Minutes. Therese's sessions are fantastic. She's able to make useful assistive technology designs from pretty much anything that you have lying around. She's very creative and a great speaker, and it all comes from requirements of a good clinical outcome. So I strongly recommend you to search for either Therese's books or find her videos on YouTube. They're very entertaining and they're very clear and entirely amazing what she's able to make. I'd also recommend you take a look at AT Makers in Florida. They're doing some really good work. And of course our forum.makersmakingchange.com, where you can discuss designs and discuss pretty much anything about assistive technology and open source. So what would be great would be is if you could take a look at our library, see what we have on Makers Making Change, see if it matches your needs, see how you like our instructions and layout, and if you've got a solution to share, we'd love to have it and help you with it. Even if you just got an idea, you can post that there as well. You can sign up for our newsletter, and we've got social media feeds and in all the usual places. So thank you very much for your time. And yeah, we're a charity, and so everything we do is supported by donations. So I've given you the URL, neilsquire.ca involved/donate. Our work is supported by donations from people like you. So thank you very much. I'm pretty much done with my talk, but I'm very happy to take any questions that you might have. So thank you very much. And I maybe keep the screen share, but if anyone has any questions, thank you.
Great, thanks, Stuart. We did have some information that came from Joan on the chat already, but I've dealt with that and chatted with her. So if anybody else has any questions at all, right now is a great time to ask, and we'll hopefully get some answers for you. So feel free to, you can also unmute. Oh, here we have one. So this is from Lyle, and he said, how does one become a maker?
Oh, good question. In my case, it was purely by accident. It was really I've been an engineer for many years, but I wasn't very practical, and I felt there was some skills I needed to learn. There happened to be a makerspace nearby that I could use, and I just started using some of the tools there, particularly the laser cutter, which if you ever have access to a laser cutter, they're about the most magical thing in the world. Well, apart from Disneyland, of course. And it was basically just getting familiarity with what I could do with each of these things, and to go from ideas to designs to devices. There is no like one path to become a maker, and if you've ever fixed something, if you've ever, really you're a maker. If you've ever thought about a problem and perhaps thought of a solution, that's a maker. And I don't really like putting heavy titles on being a maker. It's like, it's almost all of us are makers to some extent, and it's basically like, call yourself a maker, you're a maker, pretty much. That might not be a very helpful answer, but that's pretty much how I came to it.
Great, thank you. Next one is from Charles, and he said, is Neil Squire involved with any student groups? For example, IEEE student branches?
Yeah, we've worked with student groups. We have worked with an IEEE group here in Toronto. We have worked with student groups out of Queen's University. Formal links with like national student organizations, no. We tend to make them on the local college, university, and coordinator level. But if there's a way that we could introduce what we do to like groups like IEEE students nationally, we'd love to do that. But it's more on a case-by-case basis. And also I see Joan put up further at the top. We've actually worked with the company in Idaho that you mentioned. I think they may have changed the name. They used to be called Slant 3D, but they've been a great supporter of us and have made many of our devices. So, yeah, it's good that you know about them too. Any other questions? Oh, okay. Lyle just asked, which 3D printer brand do you recommend? There's lots. We have used a whole variety of them, and we currently use Prusa printers out of the Czech Republic. They're a little expensive, but they're pretty reliable. Individually, however, and in some of our offices, we've got printers like the Creality Ender 3, which is only about $250. It's not the fastest printer, it's not the most capable printer, but it does really well at low cost. We're not really about recommending particular printers, because it's what's available to you, what you can afford, what you've got space for. But these are the ones that we tend to use, but there's lots out there that are just as good. All right. Anyone else? thank you so much for coming along. It's been really appreciated. And Courtney, I don't know if we need to keep this open much
Yeah, I was just
longer.
about to say, any other questions, feel free to pop them in there. We'll just, or if, you don't have any questions, I will mention that if if you're new to Makers Making Change in particular, and you want to know more about our project, we have an information session happening this Thursday. A delivered webinar style, same thing as today. So if you're interested in that, you can find that in the events section on our website. And we do this at the end of every month. So every Tuesday, every last Tuesday of every month will be like our special topics, which you saw today. And then the last Thursday of every month will be our general info. So if yourself or if you know somebody that you think would be interested in the project, feel free to send them that way, and they can get some more info or contact any of us directly. All of our contact info should be there as well. So thanks everybody for coming. You can go ahead and sign off if you're done, or feel free to type a question if anybody has any left.